Good day, students. Okay, so I promised you a video wherein we're going to do the past or this June exam question paper, and then just show you how we could have done basically all of these questions just by knowing the basics of trig. And so here I did just a picture of all of the basics that I've summarized. It's quite a mess here, so hopefully you've done your own notes and can reference that, and that would be helpful. But let's go ahead. First, they give me a 5 cos theta equal to -4 and a tan theta greater than 0. And then they say determine the value of 2 sine theta without the use of a calculator by using a sketch. Now you recall that when we looked at those math skills that you should be able to do by level. Let me get there again, the math skills by level. Then here for trig, there we go. This is something that I should using a sketch to find the value of trigonometric expressions. And so that's exactly what it's saying here. I need to find the expression of sine 2 theta, and I need to use a sketch. Now, in order to find that, I first need to just see in what the theta that I'm talking about, in what is it? In what quadrant does this theta lie? So let me just change here. So I'm going to draw a sketch, and I first need to find out. And so you'll recall it is this part here. Where is that sketch? Here we go. Here, where we have a trig theta equal to some fraction, and another trig theta that tells us if it's positive or negative. Okay, so what we see here is that we've got cos theta is equal to -4, 5 cos theta. So I can just divide both sides with a 5 so that I have my cos theta is equal to -4 over 5. And so I see my cos theta is negative, which means if in my cos diagram, then cos is negative in one of these two. So I'm either in this one or in that one. The next thing I see is that it tells me that my tan theta is positive. Okay, so tan theta is positive, which means I'm here in this. So here I'm going to draw a triangle. Okay, and in this triangle, I'm just going to put in the values. So this is cos, which means that's adjacent over hypotenuse. Okay, let me just zoom out here a bit. I'm a bit too big. Okay, it's adjacent over the hypotenuse. And so I see adjacent, that one is therefore -4, and that makes sense because I'm on the negative axis. This is therefore theta. Theta is that angle. So -4 is here, and 5 is the hypotenuse. Okay, so all I need to do is find the opposite side length. And I can do that by using Pythagoras. And Pythagoras would say, okay, adjacent squared plus opposite squared, or you could have said, well, x squared plus y squared is equal to r squared. So either one of those two, that's fine, where x is equal to -4. And remember, the whole thing gets squared, plus y is 5 squared is equal to, sorry, y is not 5 squared, y is what I want to calculate. Apologies. Okay, so that squared plus y squared is what I'm trying to calculate, the y value, and the radius is 5 squared. And so y ends up being plus or minus 3. Okay, and in this case I know, oh, it's -3 because I'm in the third quadrant. Okay, so y is below the x-axis, so it should be negative. And so the value that I'm expected to calculate or to work out is sine 2 theta. Now, I can't do sine 2 theta. I can't do sine 2 theta because I don't have 2 theta. This is not the ratio, the triangle for 2 theta. This is this ratio for theta. So all I need to do is to simplify this using my double angle formula. So it's 2 sine theta cos theta. So for this part of the question, this was all level 1 part. So you only get two points for this. One for calculating the or getting the correct quadrant. You get a mark for, and then giving the correct value, the y value, in the correct quadrant. And then the next mark you got was for expanding this. But now you can see this is one part of the work, and this is now something else again. This is taking the expression that I have to calculate, and then first, before I can apply this, now I first need to break it up. I first have to apply my double angle formula. Okay, and now I can say, okay, well, sine is opposite over adjacent. Hypotenuse. And cos, I already have cos, is negative 4 over 5. And so this calculates to negative 3 times negative 4 is 12, times 2 is 24 over 25. Okay, so you got a mark for expanding, and then actually I think you just got a mark for the final answer. So those are the 4. It might have been 5 points. Let me just see. Yeah, it's 5 points. So you got a mark for substitution as well. So notice this is actually a level 3 type question, because what it does is it takes two level 2 questions, like one is applying a double angle formula, and one level 1 question, solving trig expressions using a graph. That is the one ability you have to do, and then combining that with another one. And so this is what level 3 is like. It's just a level 2 plus a level 2 makes a level 3, if that makes sense. Okay, so if you can do level 1 and 2, you can do level 3 type questions. So what is important is to focus on the basics, is what I'm telling you. Okay, now here they say, if sine what is equal to p and cos what, determine the following in terms of p. Okay, so here's p is sine times that. Now, what is super helpful is if you know your formulas off by heart, your compound angle formulas, because then this would have instigated something. There's a sine, cos, same angles, 12, 32, 32, 2. So what should prick your attention is that, okay, wait a minute, if I put these two together, it might be the compound angle identity that I can apply. Okay, but regardless of that, when it gets to here, when I get to this part of the question, I need to express this in terms of P and R. Now, to start, I first see, okay, but these are all in acute angle, so I need to get this thing in acute angle. So that is the first step, to get that into positive, acute, and simple. So positive, acute, and simple. Pass. That's just almost always what you will do to simplify an expression. So here we got cos of 136. So cos of 136 is cos of 180, not minus 136. You're just rewriting this as a different value, as minus 44. Okay, so you're rewriting this as minus 44. Now I can see, okay, but this is in the second quadrant. And so this becomes negative cos of 44 degrees. Okay, that's great. Now, does this help me at all? Well, hopefully now at this point you get one of the 4 marks, which is one of the 3 marks, I mean, which is excellent. Okay, I've got a third of the grades already. But now, how does that relate to these? Well, hopefully what you can see is that, okay, wait a minute, 44 is 12 plus 32. So I can say this is equal to minus cos 12 plus 32. This is a compound angle. I can break this up as negative and now put this in brackets because the negative applies to this whole thing. So just put, if you're going to expand that, put it in brackets. Okay, cos compound formula, cos, sine is same sign, different angle, so different ratios. So sine is of alpha plus beta is same sign, different ratios. So sine is plus minus, and then for sine it's sine cos, sine cos. For cos it is same different sign, same ratio. So for cos alpha plus beta, it is a minus plus. So if it's plus here, it's minus there. And now it's the same cos, sine, sine. Okay, great. So this one is the same. So it's cos 12, cos, and remember my yaw. So cos 12, cos 32. And then because that's a plus, this one must be minus sine 12, sine 32. Now, look at that. That's P. Sine 12, sine 32 is P. Cos 12, cos 32 is R. Okay, so this is literally minus P minus R. Am I right? Wait. I think I'm making a mistake. Sine is P, cos is R. So the sine, this part, let's fix that. This is R minus P. And there we go. I've expressed it in terms of R and P. Okay, if we look at the next one. Okay, so what should I have been able to do here is I should have been able to use my reduction formula to change this into 180 minus 44, to change this in, and then after that you should have recognized that 12 and 32 adds to 44. So there's a little bit of an insight element. So this borderlines on an easy level 4 question, because you kind of have to see that, but not really. It is really actually quite straightforward application, as long as you know that 32 and 12 makes 44. And so once you get there, it should have been quite clear that, okay, wait, I can add these two and then apply my but yeah, you can again see we're applying reduction formulas and we're applying compound angles. So it's again level 2 application, level 2 application. So this is at least a level 3 type question. If we now go to the next one has sine of 32. Oh, sorry, sine of sine of 2 degrees. Sine 2 degrees. Now here is definitely a little bit of a problem solving, because how does 2 relate to 44? And well, it's cos of 88. So you see, sine of 2 is cos 88. That means that and why is that true? Well, it's co-ratios. Co-ratios says that sine of theta is equal to cos of 90 degrees minus theta. So that's co-ratios. So, and here you would have seen, but this is actually cos of 2 times 44. Okay, and cos of 2 times, that's double angle formulas. And since I already have cos of 44, okay, I already know that cos of 44 is R minus P. Okay, then it's better to now express this because I have options. I can either say it's cos square minus sine square, or I can say it's 1 minus 2 sine square, or I can say it's 2 cos square minus 1. Again, you must know these formulas off by heart. You have no excuse. There's not a lot that you need to know off by heart. This is one of them. So here I can just say, okay, so this is going to be best to just use this one. So to use 2 cos squared 44 minus 1. And since I know what cos squared is, or what cos 44 is, it's just r minus p squared minus 1. And this is also sufficient to have written this in terms of r and p. Okay. Next question. Okay, given, now they give you this and they ask you to prove this identity. Okay. Again, that is a level 2 skill, is to prove identities, and especially this one. This one was superbly simple. Okay, and if that makes you offends you because you got it wrong, well, get it right. Tan theta plus 1 over tan theta. You must prove that this is equal to 2 over sine 2 theta. And so basically what you're going to do is you're going to work on the left and on the right and try and get the same answer. Now, for any simplification, you are going to do the following. Okay, and if you've watched any of my trig videos, you will know that I hammer on this a lot. Pas, cas, and das. Change everything into positive, acute, and simple. Then, so positive, acute, and simple. Simple just means if there's any compound angles or any double angles, then simplify that. Okay, positive, acute is simple. Then change everything into cos and sine, and then do algebraic simplification. Okay, so that's what you're going to do there. Let's start. Positive, acute, and simple. Okay, on the left-hand side and on the right-hand side. Okay, do I have any negative angles here? No. Do I have any angles more than 180? More than 90? No. Do I have any, well, on both sides? No. Do I have any compound angles that I have to simplify? Yes, on this side. Okay, so let's go and do on the right-hand side. Let's go do that. This can change into 2 sine theta cos theta. Okay. Next, I've done this component. Now change everything into cos and sine. On the right hand side, everything is already. So on the left hand side, now I'm going to work. Tan theta is sine theta over cos theta. Okay, plus, and then 1 over tan theta is 1 over sine theta cos theta. At this point, you already got 2 marks. Okay, if you got here, you got a point there, and you got a point there. So, so you already have 2 of the 5, I think, 2 of the 5 marks, just by doing these first 2 steps. The next is going to be to do algebraic simplification. Okay, so this is maybe a little bit more difficult for most people, because most people actually, their problem with maths is actually algebra. It's the only problem most students have is algebra. And so here what you need to know is that if I take, if I have a fraction underneath a fraction, then I have to tip and times. I like that, tip and times. So 1 over a fraction, I just multiply by the reciprocal. I turn this around. And so this one becomes sine theta over cos theta plus cos theta over sine theta. Okay, now here I can now continue to do algebraic simplification on this side. Okay, so on this side, to do algebraic simplification, I'm just going to 2 divided by 2, that's just going to, so this side is simplified. It's as simple as it can get. So on this side, I just want to do the same. I want to get it as simple as I can get. Okay, well, I'm adding 2 fractions. To add fractions, I need to have a common denominator. My common denominator can just be, can just include both of those. Now look at there. There's my sine cos. Haha, there's my sine cos. Okay, now to get this to be sine cos, I need to multiply with a sine at the bottom and a sine at the top. Okay, so this becomes sine squared theta. For this one to be sine cos, I need to multiply with a sine cos, with a cos at the top and at the bottom, so this becomes plus cos squared theta. And there we go. This is just another fundamental identity, which is 1 over sine theta cos theta. And there we go. We've proved it. And here you can see, come on, you can't tell me that was difficult. So here, the other marks that you would have gotten is simply for the common denominator and adding it correctly at the top, and then the last point went for getting the 1 at the sine squared plus cos squared, giving that 1. And there you go. Not difficult. Definitely a level 2 proving an identity. Even though there's a bunch of algebra, there was no factorization involved. Usually factorization pushes this into a level 3 because now you're adding something. This was really plain and simple level 2 proving an identity. Now here with the next question, guys, I can't tell you how disappointed I was that so few of you got this, because the moment you read hence in a question paper, en vir die Afrikaanse studente, die oomblik wat jy lees vervolgens, hence means use your previous answer or your previous result to answer this question. So hence or otherwise, but why are you going to do it otherwise if hence is going to be easier? Hence or otherwise, determine this value. Now look at that. So hence, okay, well, let's go and look at what are they talking about. Look at that. Tan of 75 plus 1 over tan of 75. This is a formula to deal with that. Tan of an angle plus 1 over tan of that same angle is equal to 2 over sine of 2 of those angles. So in other words, so this is not basics, this is just straightforward. Here's a formula, apply it. Okay, hence, here's a formula, apply it. Okay, apply what? So what it is saying is that tan of 75 degrees plus 1 over tan of 75 degrees is equal to, now let's apply the formula, tan of an angle plus 1 over tan of that angle. Sorry, I see that they used something else here. I used theta. I think this was A. X is 2 over sine of 2 times that angle. So that is 75 times 2 is 150. Okay, and so this, and remember, no calculator. They said don't use a calculator. So you're not allowed to use a calculator, which means here we now just go and apply our reduction formula. That's 180 minus 30, which means 2 over sine of 30 is equal to 2 over, and sine of 30 you should know is a half. That's a special angle, it's a half. And so 2, how many times does a half divide into 2? Well, 4 times. And there's the answer. And so here you can see, really, come on guys, you can't. And so here you can see, let's see how many points this is. This was another 5 points. So how were those points awarded? Okay, first it was for applying the identity. It's just 1 point for that. Then it was for writing it in as a, it's actually this one, for applying the reduction formula correctly. And 180 minus 30, that is second quadrant, and sign is positive in this quadrant, just so you know why there's a positive there. And then the next point was for the special angle, and the last point was for the actual answer. I think this rewriting it here. No, trying to think where that other point was given. Somewhere else, an extra point, because it's 5 points. Probably here. Okay. I would have made this 4 points because there's nothing more needed. But okay, this question paper gave you 5. Very nice of them to actually give you 2 marks for this one, I think. But anyway, that was how the points were distributed, roughly. And easy. Okay, this one was more difficult. Of all the questions in here so far, I really don't think there's any reason why I couldn't have gotten full marks if you just knew the basics. So next is determine the general solution for theta if. Now this one was difficult. It was definitely not as easy. So what are we saying? Okay, so if I just go and look at that, what is it? Sine theta cos 30, cos theta sine 30. So sine theta cos 30 degrees minus cos theta sine 30 degrees. This blue might be affecting you. Is equal to, I think it was cos 2 theta. Yeah, it's equal to cos 2 theta. Okay, now in this one, let's choose a different blue. In this one, what you should have noticed, and you would have noticed it if you knew your formulas off by heart, you would have immediately seen, oh, there you are, my old friend. Okay, there's my friend. It is a compound angle. Oh, you should have immediately seen, okay, I'm so familiar with this. I always notice them when they are there. This is sine, cos, sine. Same sign, same. So sine is same sign plus minus. So here must be a plus minus. Sine is same sign, different ratio. So this is sine of theta minus 30 degrees is equal to cos 2 theta. Now you're going to say, but how on earth did that help me? Okay, aren't I supposed to try and get everything to be the same angle? Okay, and yes, you are. That's how you do it. So how do you do that? How can I change sine into cos? Well, all you need to do to change sine into cos is to take 90 degrees minus this angle that's in there. So 90 degrees minus 30 becomes plus 30. And 90 degrees, 90 degrees minus theta. There we go. Now everything is in cos, in terms of cos. So I'm just going to simplify this. This just becomes cos of 120 degrees minus theta is equal to cos of 2 theta. Now, once we get here, okay, what all this means is that I can immediately get a reference angle. So there's a special way of solving these type of questions when I have a ratio equal to the same ratio. Then I'm going to choose either one of these two to be my reference angle. So I'm just going to make it 2 theta. It doesn't matter which one you choose. Okay, you can either choose this one or that one. Whatever is my reference angle, the other one, so some people might just say, okay, well, that means these two angles on the inside is the same. Okay, so for example, if I tell you that cos of theta is equal to cos of 30, you will say, oh, that means theta is 30. Okay, no, because cos of negative 30 is also equal to cos of 30. They're the same because cos of a negative angle is still positive. So no, theta is not just, what's inside here is not just equal what's inside there, because these are cyclical graphs. Okay, if I draw it like that, all along these points, here, 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 each time I cut it, I get another get another answer that has the same output. This x goes in and gives me the same output as when that one goes in and that one goes in. So all of them will get the same answer as when I put in cos of 30. Okay, so I can't just make these two equal to each other. I say, okay, no, I'm going to use 30 as my reference angle. And then once 30 is my reference angle, then I know theta can be 30 plus 360 degrees times k. Every time I now, so that's the angle theta there. Every time I add or subtract 360 degrees, I'm going to get another solution. But then there's this other part as well. So for specifically for cos, it's also at negative 30. So for cos, I look at the first and the fourth quadrant. So it's either by theta or by negative theta. So negative 30 plus 360. Okay. So that's 30, then this would have been negative 30 degrees, and that's also going to repeat every 360 permutation or that's added. Okay, so where k is an element of z. And so that's what I need to do here, is I need to choose one of these as my reference angle. I'm going to do 2 theta. So 2 theta. So that means that 120 degrees minus theta is equal to 2 theta plus 360 degrees times k. That's my one solution because I used cos. So let's just solve that. That means that theta, so this one is going to be subtracted on both sides. So negative 3 theta is equal to negative 3 theta is equal to negative 120 degrees plus 360 degrees times k. So now I just divide. So theta is equal to 40 degrees minus 360 times k. Now this minus here doesn't really matter. Oh, whoa. Sorry, it's not 360. I should divide it. Okay, so theta is 40 degrees plus minus 120 degrees, sorry, times k. That's important. So this must also get divided by that 3, of course. And yeah, there's my one solution. It's not my only solution though, because that is just the positive, the positive side. The negative side, just like here for cos, I use it in the first quadrant, now in the second quadrant. So now I take my reference angle and I multiply it with a negative. So the other solution is taking 120 degrees minus theta is equal to negative 2 theta plus 360 times k. So now when I add this on both sides, now I get just theta is equal to negative 120 degrees plus 360 times k. Both of these would be general solutions. So as you can see, this one definitely much more difficult. I get it, that one was more difficult, and it involved a little bit more. You should have at least gotten this first point. I'm convinced that part you should have gotten. Let's see how grades were awarded here. 1 for applying the compound angle, 2 for changing them into the same ratio so that you can solve it, and then for choosing a reference angle, and then 1 for each solution in the end. That's how the marks were allocated. Great. I'm not going to go on in this specific video. The rest was just reading off questions on the graph. I'm not going to look at that, but this was already sufficient for you to have gotten a lot of grades. I think you should have really. There shouldn't be a reason why you couldn't have gotten all these marks, because they all just rely on simple application of the basics. Maybe this part here, these 6 points, maybe. But 5, 10, 15 of these questions should have been straightforward. But the 6 was not that difficult, which would have given you at least 21 marks out of the 31. And then if you practice these are fairly common type of questions that you could have gotten, and in these two you could have gotten at least some of the values, at least 1 point there. And then here you could have also at least gotten 1 point for applying your compound angle to simplify this. Okay, great. That's me for now. Good luck. And the next video I'll make would focus on the Euclidean geometry.